Hello, and welcome to one of the very last lectures, if not the last lecture having to do with Lightwave content that we'll be doing this semester. And the reason is because we basically reached the end. What I'm saying is that with an understanding of what we got so far in terms of bullet dynamics, and with this last section that we're talking about now, we pretty much reached the end of what I can reasonably expect to cover in one course. That's not to say that we've reached the end of Lightwave. We actually haven't. There's actually enormous amounts of things that you could take much, much further. But the purpose of this course is to give you an introduction to what's possible. And so if you don't understand everything, don't let that scare you, because if you're aware of it, that's a start. And that may be about as much as I could expect of anybody, is to get an awareness and to get the skills necessary to do the basics. Because really, learning this program and learning computer graphics is a question of understanding the principles bit by bit and applying them to various applications. And every time you do another job, you reinforce what you know. It's very important that if you want to do this, that you reinforce what you've learned and that you don't stop creating things. Because honestly, every class I've ever taught is just an excuse to do more projects, because that's where you learn. So that's my pep talk for basically the end of the class. But let's get into the last horizon, let's say, of bullet dynamics, because I think it is really important that you at least be aware of it. Okay, bullet dynamics 4, this is particle dynamics, like I promised. Now, particle dynamics is a game changer. It's a sort of, we're only doing one lecture on it, but believe it or not, that's enough. When I say that, I mean that particle dynamics fits a relatively small niche in the hierarchy of what you can do in Lightwave. If you never do particle dynamics, the world will not implode, trust me. But what I will say is that if you look at what particle dynamics is, you say, wow, you can do that? And you can go further and further and further. And you can actually think, if you can think in terms of what they can do, you can begin to imagine ways to really augment what you're learning and what you're doing in other areas. And so if you are a Lightwave junkie, there's plenty more to do here. Okay, so particle dynamics is completely separate from anything so far. You know, it's completely unlike anything we've done. It's a weird idea, but not as hard as it sounds, meaning that you don't have to know much about this to get started. And it's a question of whether or not it's of any interest to you. Really, that's all it is. And particles are kind of like objects, but not entirely. So we're thinking of a particle. It's something that's hard to define. It's kind of like an electron. You know, what do you do with an electron? Well, you really don't see electrons in themselves. They have to be part of something else. And so these are very well named, actually, because particles can mean almost anything. Particles are created by Lightwave automatically, meaning you don't have to create them yourself. In fact, you can't. In fact, there isn't much you can do with the particles except tell Lightwave how to create them and what they're going to do when they're created. And so I know that sounds kind of weird, and it is. Particles have no actual substance, and they behave mostly like points. So a particle has no real substance in itself any more than a point does. If you create a point in Modeler and you take it into Layout, Layout is going to look at that and say, what do you want me to do with that? Because there isn't enough information there to create a surface. But you can assign characteristics to points that behave like surfaces. And that is probably the most succinct analysis of particle dynamics that I can give you in the useful sense, meaning that the moment you can do that, they become useful. If you couldn't do that, I don't know what you could do with particles. Particles come in clouds that behave like smoke, water, mist, or dust. So if you want steam to be coming out of a cup, you might be able to do that with particle dynamics. If you want a smoke to be coming out of a fire, or you want to create fire, you know, that could be particle dynamics as well. In fact, that's the only way I can imagine doing most of these things. You can create dust particles in the air. You can do things of that nature. And these are created using what's called a particle generator. And you can have as many particle generators as you want. Sometimes they're more useful than others. Okay, now we get into something else, hypervoxels. Now, when I traveled to Europe a long time ago, there was a car sold in Europe called the Voxel, and it was a weird car. Hypervoxels are weird too. It's another scary word. I have no idea where the word hypervoxel came from. I have no idea what the heck it is. I just know that it works. And they give substance to particles. Once you know that, that's all you got to know. In fact, you're never going to use hypervoxels unless you're in a position where you need to give substance to particles. Other than that, what the heck, doesn't matter. Okay, using hypervoxels, you can allow particles to take on different shape characteristics, which is basically another way of saying giving substance to particles. Now, the types of hypervoxels, this is where it becomes important. This opens up a whole new world. And one type is surface hypervoxels. This is hypervoxels that literally attach a surface to a particle. And the only real way to show you this is to demonstrate, which we will do. But it essentially creates particles that look like they've got some kind of a surface. They look like balloons, let's say, or globs of something. Now, volume hyperparticles look more like smoke. They have kind of like an area of a surface. And it's all done, through kind of like the same thing with procedural graphics, procedural mapping, which is all done through not obvious things, but through computer doodling. Well, the computer basically just spits that out, and it can be very effective. But that would be volume hypervoxels. Sprite hypervoxels, that's kind of like fireworks, where the actual particle kind of looks like a streak or a little firefly or something like that. You may think that's not useful, but it can come in handy. I'll show you some examples. You just have to see them to understand. You have to see how this works in order to understand why you want to do it. What do we do with particles? Now, that's the important thing. What do we do with all this stuff? We start with a particle emitter. And we look at the particles as a mass of data in the abstract. Now, at this point, you can't use VPR. So basically, the particle emitter is available only in layout. It's not in the modeler program. It's in layout because it has nothing to do with modeling. And it basically says, let there be particles. And when you look at the particles, you're looking at them in terms of what they do as a result of hypervoxels. I know we're sort of getting ahead of ourselves. But if you actually turn on VPR, you're not going to see the particles. If you leave it in the more traditional viewport, more traditional viewing strategy, you're going to see the particles as little bitty spots coming out of the emitter, kind of like radiation. And then we go from there. Now, you make sure you know what the particles are doing. Now, again, even though you can't see these until you assign them hypervoxels, you can see what they're going to do in terms of the viewport, whether it's the perspective view or the camera view. You can see that the emitter is creating particles, little spots that appear on the screen. And then you want to see what that they're doing, what you want them to do. Do you want them to be swirling around? Do you want them to be falling? Do you want them to be exploding? Do you want them to be shooting at something? So that's what you have to decide. Then you apply the hypervoxel surfaces after you've got the basics down. That's when you do need VPR, because otherwise you will never see those surfaces. These surfaces are completely invisible in the wireframe views and the surface views that you have in layout. You can only see them when you render them. So virtual progressive render is a must. And then you've got to experiment. You've got to figure out what you want them to do and enjoy the process. And that's really all it is. And this is only done in layout. Modeler has nothing to do with it. You can't see the particles in VPR unless you have hypervoxels involved. You can't see the hypervoxels without VPR, go figure. And so it becomes all that interesting. And so, yes, we have an interesting challenge ahead of us in order to understand how to begin using this incredibly useful feature. Okay, so we begin our journey into hypervoxels here in layout. We're not doing them in Modeler because Modeler has no idea what to do with hypervoxels. They have nothing to do with Modeler. And so basically here is our space, and we don't even have to create anything because at this point we don't need to do that to see what hypervoxel or what particles and hypervoxels do. All we need to do is create a creator. And so to do that, we go over to our Items tab, and we go over to Dynamic Object, add a dynamic object. And so here we can add a few things. The only one we're interested in there is particle. It's way down there at the bottom. And when you do that, you get this dialog box, which we have Add Particle Emitter. And so the name is Emitter. And so I'm going to call this emitter Charlie for no particular reason. And so it's a hypervoxel emitter, or we'll just stick with hypervoxels. I don't think there's a point in comparing that to particons. I think they're almost the same thing. But we hit OK, and suddenly we've got this little box. And I'm going to call this box kind of like a radioactive box, because if you have radiation, radioactive material, it's got particles coming out of it, and that's what makes radiation dangerous, or radioactive material dangerous. Now, if you look at the time scale down here, as I move the pointer, you begin to see particles appearing, and then it has that look. You see where it kind of shimmers there as I move it back and forth? Now, there's an important reason for that. It's got that look, you know, kind of like what a Geiger counter would show you. I hate to keep on using those metaphors, but we start with nothing, they begin to appear, then they reach kind of a point of stability, and it's almost scary. Okay, so this is our emitter that we've called Charlie, and let's see what we can do to make this more interesting. Now I'm going to zoom in a little bit more just to make sure that this is relatively easy to see. And so there's your particles. And notice they're basically points. There's no substance there. So there's a birth rate. Right now the birth rate is 100 particles per second. Now if I were to add a 0 to that, or 2 zeros, then those particles begin to do something more like that. So basically we start with nothing, and then we go to the static thing, and then you say, well, what's the problem? And then they all disappear. Okay. So you might wonder, what was that all about? Well, that's because there is also a death rate. So I basically said that I want 1,000 or 10,000 particles per second. Bang, I got 10,000 particles. My particle limit down here, how many particles am I going to allow to have, is only 1,000. So I've got to add a couple of zeros just to make that work at all. And so then if I do that, you know, then I get this again, and then I go back to my little shimmering thing. But now we got something that looks more like a shape. And so we're going to keep it like that just for demonstration purposes. It's a cloud of little fireflies that shows up, and it will stay there for a certain point. Now I'm going to add some numbers here. Right now this is 120 frames. I'm going to take this up to 1,000, even though we probably won't need that many. So if I got 1,000, you see after a certain point, it still disappears. And so let's figure out why it's doing that. So I've got a particle limit. So if I go over here to the next tab, life time frame, 60. So that's 2 seconds about. What if I were to make that 600 or 6,000? I wonder what that would do. So that will allow me to create particles that last a whole lot longer. Okay, so we may want to do that. We may not want to do that. So right now, one thing I'll warn you is particles, every single one of them has to be known by the computer. So you don't necessarily want these incredibly huge numbers of particles. And so we can change that later. But right now, we're just going to deal with a lot of particles. Okay, so those are the basics so far. Now, motion. Right now, we got a lot of particles that aren't moving. And so what if we were to tell them to explode? Let's say we take our explosion, and I'm going to take our explosion to 10. Let's see what explosion would do. Wow, look at that. So now these particles are coming out in all directions like a fire hose, and then they leave like that. It looks like hyperspace or something like that. And so I don't necessarily know what you'd want to do with that, but you could do something with it. So if we were to zoom back from this, we could see our explosion as looking something like this, looking like the sun or something. And then hypothetically that would then fade away or stay in some sort of a stable condition. So I don't know if that's useful to you, but what if we were to look at this slightly differently? So if we were to give it some velocity on the y-axis, let's say 100 on the y-axis, I wonder, then we'd have an explosion going upward. How about that? So if we were to back off here, wow. So this would be like a geyser or something like that. Maybe something we'd want to do, maybe not. And so we'd have to tailor that. We could also add maybe 10 on the x-axis to give it kind of like an effect like that. Okay, so you see we're doing a lot of weird stuff. And so what I'm going to do is I'm going to take the explosion down a bit so that it's a little easier to understand. And maybe take the activity down a bit too, so we can get closer to it. So here is our explosion. It kind of goes off like that. Maybe that's useful. Okay, so you have a few options here. And so you can see you can do some interesting things. And so that's just velocity. And you also have the ability to manipulate some of the things around the emitter. For example, gravity. Right now there is no gravity. Let's say we were to add some. And let's say I were to go -1. I wonder what that would do. But that's on the x-axis. So that may... okay, well that didn't seem to affect it much. How about on the y-axis? -100 or 1,000. See if it likes that. Yeah, okay, so that I noticed. So what happens then is gravity is very strong, and so it's actually pulling the particles down. So I'll take away 1, 0 and see what we get. So then we get, how about that? A fountain that kind of goes up and down. All right, so that I kind of like. Maybe not quite so much. So let's say we'll make that -10 so we don't have incredible. But we get a kind of like a waterfall. So maybe that's interesting, maybe it's not. But those are particles. And so the point is, this is what you can do, understanding just a simple idea of the physics that we're talking about. And so most of these other things aren't all that interesting until we get to a few other stuff which we'll talk about later. And like, for example, self-interaction. Do you want the particles to bump into each other and things like that? Viscosity, do you want them sticky? So let's put that aside for now. Let's just stick with the basics, because now we've got something at least that we can look at. And so what we want to do is say, how can we then give this substance? Because, let me show you something. If we pause it there and I were to go here to VPR, what do we get? Well, first of all, it takes a second for it to figure out that it can't display anything, and then it displays this. It displays a blank screen, because there's literally nothing there to render, because it's looking at a whole bunch of individual points that aren't connected to anything. And so in texture shaded view or in wireframe or any of these other ones, you get the ability to see the particles, but once you go into VPR, they're gone. So let's see if we can make them useful, because if you can't render them, you can't really use them. And so that's where we got to go to our hypervoxel thing. So if I go over here to Window, and I were to look up this, because it isn't on any of these tabs, oddly enough. Somewhere in there you see hypervoxels. Maybe your hypervoxels is available on a tab. I had a hard time finding it. So there's your hypervoxel tab. Now, notice my emitter is there, but it's not turned on. It's not active. Now, I don't know why not, but let's see if we can make it active. And if I click on it, it doesn't seem to want to go. So you got to kind of mash it a couple of times until you can get it to listen to you. Unfortunately, I don't understand why it does that, but you got to double click it, and you got to double click it somewhere in there, and for some reason it sticks. And this has always been the case. It's very annoying. but try to forgive the creators of Lightwave. They've done a lot of good things on top of this. Okay, so once the little check mark exists there, suddenly we have hypervoxels. Now let me prove that to you. Now first of all, the only stuff that you're going to have to do here is mostly right here on this panel. And object type right now is surface. Now remember, surface hypervoxels are hypervoxels that actually have a surface very similar to the other objects that you've seen. So now if I go to VPR, suddenly look at that. I get the surfaces. Now let's see what this does. So it starts out looking like some kind of a disgusting mess. And as I move forward here, it shoots out. It kind of looks like a water hose or something. And so this could in fact be water. So for example, if you go into your shading, go under hypertexture, or under shading rather, hypertexture, you can add textures, which are kind of like what we've been doing elsewhere. But let's say I want to change the color of the surface. This should be familiar to you. I can make this blue. I don't really want it blue though. So let's say I want to make it kind of a yellow color. That's probably better. I can make it glow if I want to, but I don't really want to make it glow. I can give it specularity if I want to. I can make it appear to be shiny. How about that? I can make it reflect. I can make it semi-transparent if I want to do that. And so there are all kinds of nutty things that you can do with this, some of which will increase your rendering time exponentially. So I seriously suggest that you not try to do stuff that will completely obliterate your rendering times, because if you haven't done this yet, you don't really have time. Okay, so let's start with something simple, basically just that. So that is if you're doing a surface render. Now, if I were to change that to volume, leaving VPR on, then I get something more like this. And so this, it kind of looks more like smoke. And that will actually work in a smoky type of a thing. So you could get it to look like that. You can also move your emitter, by the way. You can have the emitter move so it looks like a gas grenade going off or something like that. You can drop it out of an airplane and have it leave a trail of dust, that sort of thing. And so you can then also go into Sprite, which Sprite gives you this really weird effect where it just kind of glows. This could be like fireworks going off. This is great for fireworks. And if you have fewer hypervoxels, or fewer particles, it might look a little better. And so that is what we are starting to see. So you can create all this stuff. And so that's basically what hypervoxels and what particles are. And you can experiment with them and you can see if that's something that you want to do. Okay, so this is an example of an experiment in which I use some hypervoxels. So basically what we've got is a building coming down, taken down by some kind of a missile. And so you can see it's kind of in slow motion so that you can see it. And it's got kind of a weird material on the inside. Not the best animation in the world, but it shows you some of these dynamics. Now when it resets and starts again, you'll see what I'm talking about. If it resets and starts again, it's just about there now. Okay, so it starts again. Smoke, which is particles, and then basically the thing strikes the thing and so forth. And so you get the idea. So if I take it back there, you can see the hypervoxels making the trail of smoke. So how I did that was I had the hypervoxels married to or parented to that glowing object that I had strike the tower. Okay, this is an example of particle dynamics that are the sprites. Here, I literally have Fizz creating the experience. Now this is part of a VR simulation. And so you can see this is actually collectively particles creating that. So that's the important thing to understand, that these are all particles. And to be honest, I just dickered with that until I got it right. I'm not even sure how I did it anymore. Okay, so that is particle dynamics, and that's what I want you to be able to at least understand. And so be able to understand what it is, and if you can find a way to use it, why not give it a try? It can't hurt. Okay, so have a good remaining part of the semester, and I will post instructions on how to do the final exam and everything else. But from here on in, this was basically it for the content. We've reached the end of the line.